Welcome to the course Recycling for a Sustainable Future, proudly brought to you by JNARDDC, an autonomous body under the Ministry of Mines, Government of India. In this course, we'll explore the vital role of recycling in conserving our planet's finite resources, focusing on aluminium, copper, lead, and zinc. With rising environmental challenges and resource constraints, recycling has become a cornerstone for sustainability and a circular economy. JNARDDC, established in 1989 under the Ministry of Mines and UNDP, has been a beacon for the aluminum industry since becoming fully operational in 1996. The institute reached new heights in 2014 under the leadership of Dr. Anupam Agnihotri as director. In 2020, we acquired a state-of-the-art 14 meganewton capacity direct extrusion press, significantly advancing our research and capabilities. By 2023, JNARDDC was recognized as a recycling promotion body, leading national campaigns on the circular economy. In 2024, we were entrusted with implementing the S&T PRISM program for startups, fostering innovation. This year also marked the establishment of our dedicated recycling division and a strategic MOU with Daiki Japan to enhance technical expertise in recycling. Our journey is a testament to JNARDDC's unwavering commitment to innovation, sustainability, and industry leadership. Metals are typically obtained through mining, which marks the first stage of their journey. Once the ore is extracted, it undergoes crushing and grinding to reduce its size and prepare it for further processing. The next step is beneficiation, where valuable minerals are separated from the waste material using physical or chemical methods. Finally, the extracted material is processed into pure metals through hydro, pyro, or electrometallurgical techniques. These processes form the backbone of primary metal production, providing essential materials for industries worldwide. Aluminum is primarily extracted from bauxite ore. The process begins with mining bauxite, which is then refined through beneficiation into alumina using the Bayer process. Alumina is further processed in smelters through the energy-intensive Hall-Héroult process to produce aluminum. This production method requires approximately 14 to 16 megawatt-hours of electricity per ton of aluminum, contributing to greenhouse gas emissions of about 10 to 13 metric tons of CO2 equivalent per ton. This highlights the importance of transitioning to sustainable practices, including increased recycling to reduce energy use and emissions in the aluminum industry. Copper is primarily extracted from chalcopyrite, a copper iron sulfide mineral. The process begins with mining the ore, followed by crushing, grinding, and concentration through froth flotation to produce a copper-rich concentrate. This concentrate undergoes smelting to remove impurities, resulting in blister copper, which is further refined through electrolysis to produce pure copper. Extracting copper from chalcopyrite requires significant energy, around 30 to 40 gigajoules per ton, and generates greenhouse gas emissions of approximately 2 to 3 metric tons of CO2 equivalent per ton of copper. Lead and zinc are often extracted from sulfide ores such as galena for lead and sphalerite for zinc. The process involves mining, crushing, and grinding, followed by froth flotation to concentrate the ores. For lead, The concentrate is processed through roasting, smelting, and refining, while zinc undergoes roasting to produce zinc oxide, followed by leaching, purification, and electrolysis to extract pure zinc. Lead production requires about 2 to 4 gigajoules of energy per ton and emits approximately 1.5 to 2 metric tons of CO2 equivalent per ton. Zinc production is more energy intensive, requiring around 8 to 10 gigajoules per ton and generating 3 to 4 metric tons of CO2 equivalent per ton. Our planet's finite resources are under immense pressure. The Earth's crust contains limited reserves of metals, and with continuous extraction, these vital resources are depleting at an alarming rate. Metal mining and extraction also take a heavy toll on the environment, causing habitat destruction, water pollution, and significant greenhouse gas emissions. This is where recycling becomes the need of the hour. By recycling metals, we reduce the demand for virgin materials, conserve precious natural resources, and minimize our environmental impact. Prioritizing metal recycling is not just an option. It's a necessity to ensure resource availability for future generations and to build a sustainable, circular economy. Once these products reach the end of their useful life, they become a valuable source for recycling, contributing to resource conservation. For example, utensils, which are widely used in households, have a life cycle of about 2 years before they are often discarded. Electronic appliances, like laptops and phones, serve their purpose for 5 to 20 years, depending on the type and usage. Automobiles, made with components like aluminum and copper, have a lifespan of around 15 to 20 years. Meanwhile, building and construction materials, such as aluminum doors and copper wiring, are the most enduring, with life cycles ranging from 50 to 60 years. Once these products reach their end of life, recycling allows the recovery of valuable metals, reducing dependence on primary resources and promoting a circular economy. Recycling non-ferrous metal scrap involves several key steps. First, the scrap is collected from various sources like industrial sites or consumers and taken to a recycling facility. Next, segregation happens where different non-ferrous metals such as aluminum, copper, and brass are sorted from other materials. During the pre-treatment stage, manual sorting is done by workers to remove contaminants like plastics or other non-metallic materials. A gravity shaker is also used to separate metals based on weight. Heavier metals like copper sink, while lighter ones like aluminum stay on top, making further sorting easier. These steps, collection, segregation, and pre-treatment, ensure that non-ferrous metals are efficiently recycled and ready for reuse. After the pre-treatment operation, processed scrap is subjected to melting the materials, such as aluminum, copper, or brass, in high-temperature furnaces. The scrap is transformed into molten metal, which is then poured into molds for casting, forming ingots or billets that are cooled and solidified for further use. Quality control is critical throughout the process. The chemical composition of the molten metal is tested to ensure it meets the required specifications for strength, durability, and other properties. Once the quality is verified, the cast metals are used to produce semi-finished products, like sheets, rods, or wires, or finished products like electrical components, automotive parts, or industrial equipment. These steps ensure non-ferrous metals are efficiently recycled into high-quality products for various industries. First, recycling helps reduce energy consumption. Manufacturing products from recycled materials typically uses far less energy than creating them from raw resources. For instance, recycling aluminum saves up to 95% of the energy required to make it from bauxite ore. Second, recycling significantly cuts greenhouse gas emissions. By reducing the need to extract and process raw materials, we lower the emissions that contribute to climate change. Lastly, recycling helps reduce the amount of waste that ends up in landfills or pollutes our environment. By reusing materials, we minimize the strain on landfills and decrease the harmful effects of improper waste disposal, like soil and water contamination. Recycling is simple but so impactful. Let's do our part and recycle responsibly. Recycling metals is a game changer for the environment. For instance, recycling aluminum reduces greenhouse gas emissions by an impressive 95%, while copper cuts emissions by 84%, zinc by 75%, and lead by 65%. These reductions play a critical role in combating climate change by minimizing the energy-intensive processes of mining and refining raw materials. Beyond emissions, recycling is central to the circular economy. By keeping materials in use for as long as possible, we reduce waste, conserve natural resources, and ensure that products have a life beyond their initial use. Importantly, recycling aligns with global sustainable development goals. It advances SDG 12, responsible consumption and production, helps mitigate climate change under SDG 13, promotes sustainable ecosystems for SDG 15, and even supports gender equality, SDG 5, by creating equitable economic opportunities in the recycling industry. Over the past 5 years, aluminum recycling has seen significant growth as industries and consumers embrace more sustainable practices. Currently, the primary production of aluminum stands at 4.1 million tons, while secondary production from recycling has reached 1.76 million tons. A pie chart of secondary aluminum applications highlights its wide-ranging uses, from construction and transportation to packaging and electronics. It's a vital material driving sustainability across multiple sectors. The benefits of recycling aluminum are incredible. It uses only about 5% of the energy required for primary production, leading to 95% fewer greenhouse gas emissions. This makes recycling a critical tool in reducing the environmental footprint of aluminum production. Remarkably, 70% of all aluminum ever produced is still in use today, thanks to its infinite recyclability. This showcases aluminum's vital role in building a circular economy, where materials are reused rather than wasted. Over the past 5 years, copper recycling has seen remarkable growth, reflecting global efforts to embrace greener practices. Today, primary copper production is at 0.56 million tons, while secondary production from recycling has grown to 0.27 million tons. A pie chart of secondary copper applications reveals its wide use in industries like construction, electronics, and renewable energy. Recycled copper is essential for wiring, motors, and even in green technologies like solar panels and wind turbines. Recycling copper is highly efficient. It requires up to 85% less energy than primary production and results in significantly lower greenhouse gas emissions, making it a vital step in reducing our environmental footprint. Plus, 80% of all copper ever mined is still in use today. Its durability and recyclability make it a cornerstone of the circular economy. Over the past 5 years, lead recycling has seen substantial growth, reflecting the shift towards greener circular economies. Currently, primary lead production stands at 0.21 million tons, while secondary production from recycling has surged to an impressive 0.9 million tons. A pie chart showcasing secondary lead applications highlights its critical use in batteries, especially for vehicles and renewable energy storage systems. Other uses include radiation shielding, cable sheathing, and certain construction materials. Recycling lead is incredibly energy efficient. It requires up to 60% less energy than primary production. Plus, it significantly reduces greenhouse gas emissions, helping to combat climate change. Over the past 5 years, zinc recycling has seen steady growth as industries prioritize sustainability. Currently, primary zinc production stands at 0.82 million tons, while secondary production from recycling has reached 0.09 million tons. Though smaller in scale, secondary zinc plays a vital role in meeting demand and reducing environmental impacts. A pie chart of secondary zinc applications shows its extensive use in galvanizing steel for corrosion resistance, as well as in batteries, alloys, and even fertilizers. Recycled zinc supports a wide range of industries critical to modern life. Recycling zinc requires up to 75% less energy compared to primary production and significantly lowers greenhouse gas emissions, making it a crucial step toward greener industrial practices. Zinc has a high recyclability rate. More than 30% of the zinc used globally comes from recycled sources, reducing the strain on natural resources. One major challenge is that the non-ferrous metal recycling sector remains largely unorganized. This creates hurdles in standardizing processes, ensuring quality, and tracking environmental compliance. However, with every challenge comes opportunity, and strides are being made to formalize this sector. To address this, the Jawaharlal Nehru Aluminium Research, Development and Design Center, JNARDDC, has been entrusted with the critical responsibility of promoting recycling in the non-ferrous metal industry. They are spearheading initiatives to streamline operations, improve sustainability, and enhance transparency. A key milestone in this effort is the creation of a dynamic web portal. This platform is designed to collate data, assess industry performance, and provide ratings, offering valuable insights to stakeholders. It also facilitates the implementation of Extended Producer Responsibility, EPR, ensuring that industries take ownership of the environmental impact of their products throughout their life cycle. These steps represent a significant opportunity to transform recycling into a more structured, efficient, and eco-friendly process. Together, we can build a more sustainable future for the non-ferrous metal industry.